industry income, which is knowledge transfer, and international outlook, which is the diversity of your staff, your students, and so forth. You don't want all local professors, local students. Now, the Times Higher Education ranking of the world's universities for 2022 assessed 2,100 universities from 99 countries across the world. And in its final rankings, they ranked 1,662. Now, all these that fell out, because you need to meet minimum, you need to have minimum standards. So those that would not meet those minimum standards, they are not taken further into the second phase of assessment. University of Botswana was able to make it to the final stages. The University of Botswana retained its position from the previous year as the #1 university in the country and in the top 20 of Africa's universities, and remained within the second quartile of world universities. Now, the performance of the University of Botswana during the period September 2022 was notable as it maintained its relative position in Botswana, Africa, and the world, notwithstanding the challenges posed by COVID. Now, for this year's assessment, to score from 10.8 to 12.6. But remember this out of 100. While these scores and doubled, this double impact score from 13.7 to 26. This is highly commendable, and I want to really commend professors and researchers at this university. This is 100% improvement on the influence of our research globally. While these scores are still low and need to be improved for UB to achieve its ambition of research intensity, nevertheless, it is a commendable improvement on a year-by-year basis. Overall, the University of Botswana managed to maintain or improve its performance across all 5 of the performance pillars and metrics that I mentioned earlier. I therefore want to applaud the University of Botswana, its researchers, and I'm very, very excited that today we'll have presentations from our young, promising, highly passionate professors that are here with us today, Memkwa and Masuabi. And of course, not very young, my old friend here, with that, colleagues, I'm saying the University of Botswana is on a direction of enhancing and spearheading the transition of Botswana's economy to what you call a knowledge-based economy. Thank you very much. And thank you very much, Director of Ceremonies, that took a bit of time. Be impatient with me.
Thank you so much. We really appreciate you, Professor David Norris. Colleagues, ladies and gentlemen, I please ask those of you who are joining us through the web on Zoom to mute your mics. Apparently, there's a lot of feedback. Can we please mute our mics so that we can have a meaningful and productive session? So Professor Norris has said quite a lot, and I'm sure some of us may want to ask him 1 or 2 things before we get to the researchers. One of the things I think that is so important that I just want to say is that really as incubators for knowledge and knowledge transfer for the economy, we should be the drivers of the economy. So I'm going to give maybe just a couple of questions which can come from the floor or from those of you who are online. I'm monitoring the questions. And may I just repeat that you please mute your mics Those who are listening online says there's a lot of feedback. So I'm just going to give a minute to see if there are any questions, and then otherwise I'm going to introduce our next speaker. Okay, I haven't received any questions online, so I'm going to assume that we can ask questions. There'll be an opportunity later to ask questions. So our next speaker is going to be Dr. Bokang Masuabi. Dr. Bokang Masuabi is trained as a doctor in the Czech Republic and then did a PhD with a focus on hemato-oncology and immunology. So his research focus is actually in hemato-oncology, which is like the cancers that affect the blood, and immunology, which is the way that our bodies respond to challenges, to whether it's infection. You know, we all hear about masolamele or our blood cells, but there are other things that the body uses to fight disease, and that's his area of research. Currently, he's working at the Faculty of Medicine in the Department of Biomedical Sciences as a pathophysiology lecturer. His research interests, they include immunological disorders, hemato-oncology research with a focus on leukemia and lymphoma, which are cancers of the blood. And his current research is focused on new assays development. This is now going to be quite lingo that he has to explain later. And high dimensionality data analysis. He is the principal investigator in the project titled Immune System Dysregulation in COVID-19, which I welcome him to explain. Dr. Masuabi.
Thank you very much, Dean Komazana, for the kind word. As we all know, the currently ongoing outbreak of the severe acute respiratory syndrome coronavirus 2 pandemic broke out in December 2019 in Wuhan, in China. Immediately when these first few cases were identified, there was a huge interest in the scientific community because it was realized very, very fast that this could be a disease of global importance. Anyway, it was already noted because before, around in 2003, a similar disease had broken out, which had been defined as severe acute respiratory syndrome. So this became number 2. And again, similarly, in around 2012, another disease, Middle East respiratory syndrome, had broken out. This was what was known at that time, that this new disease is similar to this, based primarily on how the patients presented. The scientific community got to work, they became mobilized, they started to look at this new virus. They were able to sequence it to know how this virus is, and they gave it the name Severe Acute Respiratory Syndrome Coronavirus 2, or SARS-CoV-2, and the disease was henceforth known as COVID-19. And of course, from that point, I think our whole lives changed the world over. At the same time as this disease was progressing, we here in University of Botswana, we were also following developments. And if you remember, in December 2019, January 2020, we were not so much affected. We saw what was happening in China, we saw what was happening in Italy, but it was a little bit far removed from us. But we as scientists, we recognize that this could be very important. It was a disease which was spreading, going to countries slowly, and we knew that one day it will come to Botswana, and we decided to become prepared. So we met as a group of enterprising scientists in the Faculty of Medicine, Department of Biomedical Sciences, Department of Pathology, Department of Internal Medicine, so a multidisciplinary team, and we met and we said to each other, what can we do? What can we find out? How can we prepare? And we said, in order for us to do something, First, it has to be people-centric. It has to apply to us here in Botswana because most of the data at that time was coming from China. A lot of the data was coming from Europe. So we said, let us do something which will be centered on Botswana. The information, the research will, and the results will reflect the picture which occurs in Botswana. Do should reflect, of course, our talents. So we looked around at the pool that we had and looking at the talents, at our specialities, at the things that we are able to do, we came up with the idea to start a project. And this project, we titled it Immune System Dysregulation in COVID-19. So we wanted to study what happens to the immune system in people who have been affected with this disease. And just to remind you, when we were writing all these ideas and meeting to discuss what we can do, here in Botswana, we had about 24 cases. We had 24 cases, and almost all of them, except 7 cases, were imported. So it was again still a very, let's say, abstract disease. It was something which was still outside of our country. But still we sat down and said, when it comes, let us be ready. So we came up with this idea, we came up with this project, and we sat down to establish the objectives. And the main aim was to look, as we say, at blood cells or immune cells and how they react. So we wanted to look at all the cells in the body. We wanted to look at the immunoglobulins which are produced when a patient becomes infected. We wanted to look at the messenger molecules which drive the reaction of the cells, because our cells in the body, they communicate somehow, and they use molecules for this communication. I'll use the word cytokines for this. So we wanted to look at these molecules which communicate and to try to see what is going on, because nobody knew nothing except it affects the lungs. The people rapidly become breathless, and then they die because they can't get oxygen into their bodies, even if they are supplied with oxygen. So we wanted to see at the pathophysiology or at the interaction of the various body systems with the immune system, what occurs. The project had 5 main objectives. The overarching one, or the general big one, of course, was to look at the immune system individually, the cells, the molecules or the cytokines, and to look at the antibodies, because we know now, I think it is quite common now, that once you become infected with COVID, you develop antibodies. Or if you are immunized by all the various vaccines which are available, you should develop antibodies. At that time, nobody was speaking about vaccines. So we wanted to actually follow antibodies which developed or which resulted from being infected with COVID. So that was the first measure aim. Then the second aim which we wanted to look at was to look at the virus itself. We had been told about the virus which was in China. We had been told how it looks like, but we were interested to know was if the virus which is now here in Botswana, because most people were coming from outside, from UK primarily, is it the same as the one in China? Is it the same as the one in the UK? Most of them went through South Africa. Is it the same as in South Africa? And here I must say that at that point, there was only one virus, but of course now we know that people are now speaking of alpha, people are speaking of beta from the UK, people are from South Africa, people are speaking of delta from India, and gamma, America, and so on. So at that point, at time, which was around May, we were primarily trying to just see on the small patients which we had in Botswana, where is our virus from and how does it look like? Because again, this information was missing. We were being told by the Asians what is there, we were being told by the Europeans what is there, but what about us? So that was the other aim. The other interesting aim which we had in respect to this project was we realized that we had very little numbers. As I said, when we were writing this project, we had about 24 cases. And we were wondering, why is this virus not affecting us the same as other people. We heard that if you had the virus and you were in contact with other people, it was a respiratory virus, so you could give it to other people. Yet we had people, we know they came to Botswana, we know they went to their families, they subsequently tested positive, but when we evaluated the people they were in contact with, they were negative. So we wanted to look at these people, again, to look into the bodies of Botswana. Is there something maybe which is, let's say, protecting us from easily contracting the virus? Because we did contract it, being contacted, but we thought that maybe it's a little bit very hard to contract it, as opposed to Italy, for example, as opposed to Wuhan. So that was one of the aims, to look at people, or what we called close contacts, and to see if there is anything which might be conferring, let's say, immunity to these people. And the last aim which we had was to try again to look at what parts, how exactly does this virus affect our bodies. We had already been or seen that it was primarily a virus of the respiratory system or the lungs, but the reports were already coming. Other organs were also being affected, the brain, the liver, the kidneys. So we said, let us also look at this and say, in Botswana, the virus primarily affects this. We know now that there is the acute syndrome of COVID. We know that there is long COVID, and we know that the virus spreads into many parts of the body. So we wanted to look at that. We wanted to look at that by doing postmortems of maybe a few, let's say, patients, but also to look at, let's say, high resolution imaging. So here I'm speaking about magnetic resonance imaging, MRI or CT scans, whole body CT scans of patients, and to see what changes, and also to take some small samples of different tissues, look at them under the microscope, and see, is the virus there, or is the damage which occurs being caused by the immune system. In conclusion, the big relevance for us, or the big motivator I want to stress, was we had first the idea that we want to build capacity. We did not have this type of research before. There was the Middle East Respiratory Syndrome, which passed. There was the SARS, the first severe acute respiratory syndrome, which passed. Those were not pandemics, but they were epidemics. And already around the world, people had already that capacity to look and to respond very, very fast to these types of things. So we wanted to capacitate first ourselves, so that we have something like this now here in Botswana, which in the future can respond very fast to any new disease or any new variant, as now we have variants. Then the second thing, which was also a very big motivation, as I already said, was to look and do research which is Botswana centered. Because as you all know, a lot of the information which is now coming is coming always from outside. We are taking now various vaccines. We are changing our recommendations, and most of the time, this is based on research which is published outside. And we believe that if we develop this capacity, we will start where we start at the beginning. Next time, we have the capacity now to say, when we give Botswana Sinovac, when we give Botswana Moderna, when we give Botswana AstraZeneca, what happens in the bodies of Botswana, which is best for us? Because these vaccines, for example, developed somewhere with in countries with different socio-economic burdens. Tuberculosis is very Chinese or to Europe. HIV is a disease that we live with. We have a huge disease burden of infectious diseases. So that was the other big motivation to be able for today and also into the future to create answers which answer questions and problems which are in Botswana. Thank you very much.
Thank you, Dr. Bokang Masuabi. He is very passionate about what he's doing. Because I see that we might have a time challenge, I'm going to allow just one question to Dr. Masuabi and then invite the next speaker. And then we'll see how much time we have at the end to ask questions. Is there any question here or online? I see Professor Kasoso. I don't know how they're going to deal with the mics. Okay, fantastic.
Thank you, Dr. Masuabi, for your wonderful presentation. I just wanted to know, since the launch of your study, whether you have started to accrue any data and what is the data suggesting as of now? Thank you.
Thank you very much. Unfortunately, we haven't yet begun our study, but we are hoping that in the next month, 2 months, we will begin.
Thank you, Professor Kasoso. That's a very important question, because as much as we want to respond speedily, sometimes our machinery is not very fast. So I'm just going to leave it there, because I think people who a new disease breaks out and already they are coming up with vaccines, the facilitating processes enables them to move with speed. But that is just something that as we set ourselves as an institution and as a country, that we would have to address those issues. Okay, so now I'm going to move on to something completely different. I'm going to be inviting Dr. Shatani Nkwa. Dr. Shatani Nkwa is a biomedical engineer by training, and we actually employed Dr. Nkwa not that many years ago. She's not that old. She came in as a staff development fellow, and then she has done a PhD in biomaterials and tissue engineering. And now she's a senior lecturer at the Faculty of Medicine, the Department of Biomedical Sciences. Dr. Nkwa is a go-getter. She doesn't take a no very easily, and she actually doesn't take a no. Since she came back from the University of London, she had wanted to establish and biomaterials. And I remember the conversation we had, because the equipment cost so much money, and she had just come out of PhD, and our discussion went something like, Dr. Nkwa, when my daughter just gets a license, I don't buy them a Mercedes-Benz, I give them a Maufiti. And she was insistent that she was worth not even a Mercedes-Benz, but even better. And so eventually she found her way, and she has founded a regenerative medicine lab at Saikitumela Masire Hospital. And her career objectives are focused in finding affordable means of advancing regenerative medicine and medical device fabrication in Botswana. And so this morning, she's going to be showcasing some of her work, and some that have already actually been practically applied to solve real life challenges. Dr. Nkwa.
Thank you, Professor Nkomazana, for that lovely introduction. Today I'm going to present to you some of our works here on pre-surgical planning and medical device fabrication. So I'll start off with pre-surgical planning. Why pre-surgical planning? The aim is basically to assist and help our doctors in providing personalized precision medicine to our patients here in Botswana. So I'm going to demonstrate what I mean by this. 2 years back, we received a grant from Lloyd's Register Foundation. And in this grant, we had Dr. Kebaetse as our rehabilitation scientist, and Dr. Papelo Muntiwa as our clinical surgeon, and me as the principal investigator of that project. So what I have here, I don't know if you can see this little model over here. What I have here is a reduced model of the work that was done. So what we did is our surgeon had a patient case which was quite complex, and what he realized was for the corrective surgery he needed to do, with our patient who had a knocked knee medical case. We can call it genius valgum. This is when the knees are closed in together. So our surgeon wanted to correct this. And what we realized is we would need a patient-specific implant for this to work and for our patient to be assisted. So we got a grant from Lloyd's Register Foundation. We then used that grant to obtain a CT scan of our patient. And from the CT scan, we isolated the anatomical defect site, printed out a prototype for our patient, for our surgeon to practice and plan the surgery on. At that time, we didn't have a 3D printer within the Faculty of Medicine. So this model that I'm displaying here is 1/3 the original size of the, yes, 1/3 the original size of the real patient model. So this was printed, the real patient model was printed at Bitry because they had the large 3D printing machine which could print on a 1:1 scale. We then gave the surgeon this prototype to plan the surgery. He planned the surgery and gave us an idea of the type of implant design he would need. And our implant design was then 3D printed in titanium at Central University of Technology in South Africa. Before this implant was 3D printed, the file was sent back to Botswana. We loaded it on a software where we sit down with the surgeon and we simulate the surgical procedure, and the surgeon determines whether he's satisfied with the design before he can go ahead fully with the surgery. The surgeon was satisfied. The implant was printed in titanium and it was delivered here to Botswana. And our surgeon was able to conduct the surgery successfully. Now, after the surgery, our patient went through rehabilitation. Our rehabilitation scientist, Dr. Gebaete, did that work. And now, actually, you find that we had proper knee alignment as compared to the left leg because the right leg of the patient was affected. The patient before had a lot of falls, but now the patient didn't have a lot of falls. The patient before had lower back pain, now the patient didn't have lower back pain. And the patient had increased self-confidence because the walking alignment was improved as well. So this is an example really of a case that was done here in Botswana at the Faculty of Medicine by our staff in the University of Botswana. Now, to further demonstrate the pre-surgical planning, I have included a breast cancer model here. I don't know if it can be shown. We have a breast cancer model there. Now, we know that in Botswana, we're seeing a rise in cases of breast cancer among the women in our country. And so what you want to do as a doctor is when a patient has a tumor, something like this, our doctor can come to us and say, Dr. Nkwa, I need to do a 3D reconstruction and get a 3D model of my patient's tumor, because I need to explain to my patient exactly what is going on and how deep this tumor has penetrated within her breast. This is also important for the patient because they will get better understanding of exactly what is happening in their body. And when they give the surgeon consent to go ahead with surgery, they would be giving informed consent. The surgeon can also use this same model to explain to the patient's family, because at that time the patient may be going through anxiety and depression, and they will need support from the family. So with this, the surgeon can then explain to our patient and say, this is the tumor, this is how bad it is, and this is why I may have to remove all of your breast instead of just removing the tumor. Again, our surgeon can then ask us to print the tumor on a 1:1 scale. So what I had here before was half the original size of the breast, but this tumor is the exact scale of the tumor 1:1 that the patient has. The doctor can then take this tumor and say, this is what we will expect to remove from you if we're going to take the route of just removing the tumor alone, right? And so the patient will understand better exactly what is happening to them, as well as their family members. Now, after doing all this, these same models can be used for educational purposes amongst our medical students. For example, this model where the surgeon had asked for a patient-specific implant, this can be used for educating our medical doctors practicing surgery. The same with the breast cancer model, and other models can also be made for different educational purposes to enhance our learning mechanisms within our institutions. Now, I'm going to move on to medical device fabrication. With medical device fabrication, I have an example here. With the start of COVID, we all know that in the Americas and the European countries, they were developing and fabricating materials for themselves, PPEs and other materials to assist or help in the fight against COVID. At that time, I contacted some universities in America as well as Europe, and they shared with me, because I have the same equipment as them that can produce these medical devices, they shared with me the nasal swabs that they developed for their people within their countries that they use within their hospitals to collect the COVID samples from the nose. So we have 3 different swabs here which were shared with me, 2 from America and 1 from Spain. And so as an example, these are the things we should be and are doing for ourselves here in Botswana.